Hello friends, Vidura here. I wanted to report shortly some odd observation which I made by accident. I have here built up an H-bridge with the switching modules, and I have one of these transformers. It is purely non-inductive. It has exactly the same numbers of turns bifilar, and I have attached a ground wire on the center tap. Okay, and when I connected it, I was surprised that there was no current drawn from the power supply. As it is non-inductive, there should be a lot of current. But then I realized that I have inverted two of the signal connections. So instead of crossover switching, I had simultaneously the high switches and the low switches on. And I observed a very interesting effect. I use the scope probe as antenna for the tuning, as it results easy. You can detect easily the behavior of the electric field in the setup. So yeah, and what happened? Firstly, the strange interference in the power supply, which is isolated by filter capacitors and all this, but the interference is there. And when you see, I have here the waveform from the scope probe, which acts as antenna. You can see it is now tuned in longitudinal form. This means that the switching occurs exactly on the peak, on the positive and then the negative peak of the sine wave, which gives rise to a longitudinal waveform. Yeah, and so there is everything here, all the circuit. If I go near the MOSFET dissipators, there is the wave. In any of the MOSFET switch, it's all the same. You can see here from this angle. Even the power supply, the connectors from the power supply, with filtering and all, there is the same wave present. Also in the wire from the driver power supply, it goes through all parts which are attached to the circuit. And okay, now I will, for comparison, I will remove the ground connection. You can see now we have a small reading of the square wave from the H bridge, but the oscillation goes away completely, and the power supply becomes normal. Okay, I wanted to investigate this a little bit further, so I did this test inspired by the setup of Chris. I put a current sensing resistor in each wire before the tap, for the grounded center tap, to see if the current are actually opposing, because they should not, as we have simultaneously always positive on both ends and negative on both ends of the coils. And now when we see here on the scope, the lower traces are current, and actually these current spikes are opposing. If we zoom in here a little bit, more, and now in 100 nanoseconds, and you can see that each and every of this trace is exactly mirrored from the other coil. So even this bouncing, these oscillations at very high frequency, it's in the range of 10-20 megahertz maybe, it is all exactly 180 degrees out of phase, which would give rise to a magnetic standing wave, obviously. Okay, I leave you to make your own conclusions from this. Thanks for watching.